Yes, this is assignment number 5 of alcohols, phenols, and ethers. First question, as usual, is nomenclature. This is CH3, O, CH2, CH2, O, CH3. Very simple compound. This is 1,2-dimethoxy-ethane. I'll repeat, 1,2-dimethoxy-ethane. Second is functional isomer of 1-propanol. You know, alcohols and ethers are functional isomers of each other. Propanol has 3 carbon atoms. There's only one ether which has 3 carbon atoms, and it is methoxyethane. So this is the functional isomer. Second question, fill in the blanks. A is a branch chain compound, and it has 4 carbon atoms. Hot copper means oxidation, and you have come across hot copper as oxidizing agent for alcohols. So A is a 4 carbon branch chain alcohol, put it this way, which with hot copper gives B. Now we don't know whether this is primary or tertiary alcohol. These are 4 carbon atoms with a branch. OH group can either be attached to a primary carbon atom or to a tertiary carbon atom. With hot copper, primary will give aldehyde and tertiary will give alkene. Now B with the KMNO4 H plus means further oxidation of B gives C. Now further oxidation of, if it is aldehyde, then product will be carboxylic acid. And if B is alkene, then further oxidation will lead to the formation of what you call acetone. Now next says C reacts with A in the presence of sulfuric acid. This reaction is esterification. It means C should be a carboxylic acid. If you want, I can write it. A is one of these two. With hot copper, this will give alkene. This will give aldehyde. B is one of these two. Further oxidation. This on oxidation will give ketone. This on oxidation will give carboxylic acid. C is one of these two. And the C is reacted with A. A is alcohol. This does not react with A, but this reacts with A. Carboxylic acid with alcohol will lead to the formation of ester. It means this is wrong, this is wrong, this is wrong. A, B, C, and last product is this is the ester obtained as the last product, that is D. I think you can see now. Coming to second sequence. Alcohol means ethanol. With A gives B, B with C gives Grignard. It means B should be an alkyl halide, that is bromoethane. How do we convert ethanol into bromoethane? We can use NABR sulfuric acid. This is in situ preparation of HBr. Reaction will lead to the formation of bromoethane with magnesium diether, will lead to the formation of ethyl magnesium bromide, which is given. Now this Grignard on reaction with D gives normal propyl alcohol. It means D is HCHO, methanol. Now one normal propyl alcohol with ethyl Grignard will lead to formation of alkane corresponding to Grignard, that is ethane. And the second product is alkoxy magnesium bromide. This is propoxy magnesium bromide. Third sequence. This is, if you remember, this is a method of preparation of phenol. This sodium salt of sulfonic acid is mixed with solid NaOH and the mixture is melted. So in third sequence, A is NaOH in the solid form, uh, gives carbolic acid. Carbolic acid with carbon dioxide T and P. This is what? Nothing but Cobb's synthesis for the preparation of salicylic acid. So temperature is 400 Kelvin. Pressure is 4 to 7 atm. B will be sodium salicylate, OH, COONA, and C will be salicylic acid. C is salicylic acid. Next, A with hot copper means oxidation gives methanol. It means A is methanol. Methanol on oxidation gives HCHO. This HCHO with B gives isobutyl alcohol. It means B is a Grignard reagent. This is isopropyl Grignard. Now this isobutyl alcohol with acetic anhydride will give an ester and carboxylic acid. Ester will be, this will be the ester, and carboxylic acid will be ethanoic acid. Last sequence. A with aqueous KOH gives B. B with this dehydration gives C. C with the next reaction is hydration gives D. D on oxygen, I think will go reverse. Last product given is tertiary-butyl alcohol. For tertiary-butyl alcohol, one reactant given is E, the other is methyl Grignard. It means E is acetone. Acetone is obtained by oxidation. It means D is 2-propanol. 2-propanol is obtained by hydration of C. This is propene. Propene is obtained by dehydration of B. This may be 1-propanol or 2-propanol. For B, two answers are possible. And B is obtained by reaction of A with aqueous KOH. Not aqueous KOH, it should be alcoholic KOH. It means A is, this is aqueous. This is 1-halopropane or 2-halopropane. If A is this, B is this. Second option. If A is this, then B will be this. Sorry. If A is this, then B will be 2-propanol. Coming to fourth question. What happens when? I'll tell you verbally, very simple questions. Phenol is heated with zinc dust. It undergoes reduction to give benzene. You'll write the balance equation. Phenol is treated with bromine water. You'll write balance equation and write that bromination takes place at ortho and para positions. Bromine water is decolorized and white precipitates of 2,4,6-tribromophenol are obtained. Conversions. Phenol into benzyl. Wait a minute. Yes, phenol into benzyl alcohol. First, convert phenol into salicylic acid. Or I'll use another method. Convert phenol into benzene. Zinc dust heat. Convert benzene into toluene. You know the method. It is Friedel-Crafts alkylation. Convert toluene into benzyl chloride. Even this, this is halogenation in the presence of sunlight, side chain chlorination. Last step, react with aqueous NaOH, you'll get the final product. Oh God, nobody speaks out anything. This question was distinguish between. Children, do you ever look at the assignment? No one pointed out. This question was distinguish between phenol and benzyl alcohol. We can use bromine water test or we can use ferric chloride test. In both the cases, positive test will be given by phenol, not by benzyl alcohol. Of course, balance equations have to be written. Methanol and ethanol. This you can distinguish by anyone. Tell me which test can you use?
Sir, Lucas reagent test.
Which one?
Lucas reagent test.
Lucas reagent test is to distinguish between primary, secondary, and tertiary alcohols. This cannot be used here.
Iodoform test.
Iodoform test can be used. Ethanol will give iodoform test. Ethanol contains required group for the preparation of iodoform. So we can use iodoform test, right? Next, conversion. Ethyl alcohol into glycol. First reaction is dehydration, concentrated sulfuric acid 160 to 170 degrees centigrade. Then react with bromine water, you'll get vinyl dihalide. Last step, react with aqueous NaOH, you'll get the final product. Ethanol into propanoic acid. Ethanol into alkyl halide. You know many methods. Alkyl halide into Grignard. Grignard into 1-propanol. This is a reaction with HCHO. And last step is oxidation with acidic KMnO4 or acidic potassium dichromate. Next, ethyl alcohol into secondary butyl alcohol. Ethyl alcohol into secondary butyl alcohol. Oxidation gives aldehyde. React this aldehyde with Grignard, ethyl Grignard. You'll get the final product. Chlorobenzene into aspirin. Convert chlorobenzene into phenol by Dow's process. Convert phenol into salicylic acid. Phenol into salicylic acid, you know two methods. One is Cope synthesis, or you can use Remer-Tiemann reaction by using carbon tetrachloride. Any one of these can be used to convert phenol into salicylic acid. React this with acetic anhydride. Acetylation, you'll get the final product. Ethene into 1-propanol. If I make this conversion very small, convert ethene into HCHO. This is ozonolysis you studied in 11th standard. O3 followed by water in the presence of zinc. If you do not remember, I'll tell you the alternative. React this with ethyl Grignard. If you don't remember, let us try this one. Add HX, you'll get haloethane. Convert haloethane into Grignard. React Grignard with formaldehyde, you'll get the final product. Benzene into salicylic acid. This will be part of the conversion we did earlier today. Convert benzene into chlorobenzene. After that, use conversion number 4. You'll find all steps in conversion number 4. Next, out of ethanol and 2-propanol, which is more basic and why? This is based on plus I effect. More the alkyl groups, more the plus I effect, higher is the electron density at oxygen, easier the donation of lone pair, and more the basic nature. So answer is 2-propanol. Give IUPAC names of functional isomers of ethoxyethane. There'll be 4 functional isomers, all naturally will be alcohols. And these isomers are 1-propanol, 2-propanol, 2-methyl 1-propanol, and 2-methyl 2-propanol. These are 4 functional isomers. Then we have to write metamers of ethoxyethane. Ethoxyethane has 4 carbon atoms. Its metamers. 1, 2. These are 2 metamers of ethoxyethane.